Was your first binder check. The scores will hopefully be in today and you'll see how it's affecting your grade. Honestly, I expected better. Like taking notes and keeping them is step one. Like you're allowed to use notes on your quizzes. I don't know why you wouldn't have notes to reference, especially if you were absent. Your job should be to watch the video lessons, take notes on your own. You don't need the papers that I hand out, but I've told you like since day one, you're welcome to grab them. They're in that bin over there. I gave you the list of everything that's supposed to be included. So when you guys are like, oh, I'm not sure if this is a page or not, I don't know what to tell you. Like the list is there. You had all this time to like think about it and ask about it. I only counted the ones that were from the list and that had the parts we did on them. So like some of you showed me just like blank papers. Those didn't count. And a lot of you are missing a lot of pages, but I don't know what to tell you. You can do better on the next one. You can resubmit this one, but then I need to see your entire binder again because I'm not memorizing what each individual person was missing. So if you want to resubmit it, I'll put a date in the grade book for how long you have it to do that. But really, like to do it after a unit test is kind of like no longer in the best interest. So that is going in your project category. That's supposed to be a good grade to kind of like fluff up your grade before the unit test. But for some of you, it'll bring your grade down. I mean, I don't know. You need to take notes. You can use notes on quizzes. That's like step one for being successful. Yeah, it's yeah. In fact, let's take a look because some people have confusion about that too. So everything, like, I mean, there's not usually a whole lot of paper assignments in here, but anything that is ever assigned in here is always linked in Schoology. Your study guides will always be like right at the top where you can't miss them. Here's the Unit 1 constructed response practice tests linked here for those that are absent. But again, like, I've never been the type of teacher to like when you come from an absence be like, oh, here, sweetie, here's everything you missed. Everything's in Schoology. It's always your guys' responsibility to get that done. So this is where you can upload it if you didn't get full points right now when I checked it. But yeah, the binder check, I don't expect you to upload, but if you were wanting to resubmit it for more points, then you need to show it to me really anytime that I'm not teaching. It's now your responsibility. I'm not going to ask for it again. It's only if you want to improve your grade. So yeah, today's really your only day to ask me questions in person. Tomorrow I'm going on a Stuco field trip, so I won't be here. You'll have tomorrow we have a list of things to do tomorrow, but tomorrow's also the deadline for any late work from Unit 1. So after that deadline, I do not have to accept it for full credit. And then right now you have time to ask me questions on either portion of the study guide. So what questions do we have? Also, I have tutoring today after school until 3. No questions? You're all gonna ace it Thursday? Did we look at the study guides? Yes, Jovi? Um, all right. The one that says the dot plots show that one? Okay. So we have the dot plots show number of hours of video games played in a day by 2 students, Jerome and Sarah. Select all statements that must be true. So what does that mean? Select all that must be true. There can be more than one. Sometimes there is just one, but you need to evaluate every single answer and determine if each one is true or not. So for this one, sorry, I can't see my mouse, so let me make it visible. Okay. So for this one, we have the mean and median values for Jerome's data are about the same. So just looking at Jerome's data, how do you know if the mean and median are about the same? Do I have to put it in the calculator? No. Could I if I was really confused? Yeah, but then that's also a time waster on a timed test. Remember, you're supposed to be able to do the online portion and the paper portion within the same hour. You do not get extra time. So how do you know if the mean and median are about the same without having to put it in the calculator? If it's symmetric, so is Jerome's data symmetric? So the mean and median are not about the same. All right, so we're not gonna select that one. Yours could be shuffled on your screen, so don't just blindly pick. But we're not gonna pick that one. Next, we have the mean and median for Sarah's data are about the same. What would you guys think? Is Sarah symmetric? It's definitely more symmetric than Jerome's. Is it perfectly symmetric? No. However, what I'm gonna think the test is gonna lean toward is that almost perfectly symmetric will kind of count as the same. So we're gonna select that one for now. We could change it later, but the mean and median values for Sarah's data are about the same. And again, we could also put it in a calculator and tell us. But there's a lot of the same number in the middle, so I'm gonna go with that they're about the same. Next, we have Sarah's standard deviation is higher than Jerome's. How can I tell whose standard deviation is higher without doing the math? So how spread out it is, more spread out would be a higher or lower standard deviation. More spread out would mean a higher standard deviation. So whose looks more spread out, Jerome's or Sarah's? I think Jerome's. Because for Sarah's, like her mean will be toward the middle of her data, and all of the data is clustered around the middle. Whereas Jerome's, his middle is probably more like over here, and the data is clustered away from it. So, I mean, again, you could put it in the calculator and compare the numbers if they're close. I'm gonna say that Sarah's standard deviation is lower than Jerome's. And then if I have time on my test, I'll go back and do the calculations. Next we have the median values for both students is about the same. You guys agree with that? Does the middle look about the same for both? Visually, I'd also agree no, because again, Jerome's middle looks like around here. Sarah's middle looks around there, so like not quite the same. So I'm gonna go with, don't pick that one. The mean values for both students is about the same. What do you guys think? The mean values? See, now that one I would probably for sure compare in a calculator because, so I'm just kind of making a note to myself to calculate the means for both and compare. Because Jerome's has some outliers over here that are gonna pull the mean higher than where the median is. So it could be that theirs are gonna be comparable in the end. So that one I might actually have to calculate to be sure, because it is close. Then we have, if Jerome stayed home sick from school on Tuesday and played 10 hours, this would affect the mean value for him more than the median value. Okay, so if we add a plot of 10, which isn't even on my number line, we have to extend the number line and then put a dot like around here. Would that affect Jerome's mean more than the median? Yes, any outliers, which 10 would probably be an outlier, will affect the mean always more than the median. So I'm gonna definitely select that. Now, if Sarah stayed home sick from school on Tuesday and played 10 hours, this would affect the median value for her. Now, see that one, I do feel like I need to put in the calculator because it didn't say like affect more than the mean or anything like that. It just said affect. And so even if the median changes a little bit, that would count as it being affected. It could also not change depending on where we're putting it. So that one I might actually have to calculate. So far, I'm pretty confident with these three answers without calculations. I do want to compare their means, and I definitely want to compare Sarah's median. So let me show you that. Remember, I can't help you with the calculator during testing. So you will still have Desmos available to you, but you have to know how to put in your data. So like from a dot plot, like Jerome's here, I'll even make it a J for Jerome. He has 5 zeros or ones. And then, so just slowly putting in the rest of his data. 5, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so that makes sense for Jerome. For Sarah's data, let's see. Okay, so 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay. So first we wanted to compare their means because we have that the mean values are about the same. That I wasn't sure about. So let's compare. The mean for Jerome is 1.75. The mean for Sarah's is about 3.3. Now, comparatively speaking, like these numbers are not far from each other on a number line. However, the data set is kind of small already, like it's only has number lines going from 0 to 8. So comparatively speaking, I would say that they are not about the same. Okay, so we're not going to select this one where the mean values are about the same. But I also did want to see the answer to this one. Like if Sarah stayed home sick from school on Tuesday and played 10 hours, would it affect her median? So let's see. So I'm going to erase this. I'm going to find the median of Sarah's, which is 3 before we add that value of 10. Okay. So I'm going to add that value of 10 and it did not change. So adding that value of 10 did not change her median. Even if it changed a little bit, like if it went from like 3 to 3.1, then we would select that one. But it didn't change at all, so we're not going to select that one. So that went from calculating every single answer choice to maybe only checking a couple things that were close. And it's completely right if you select these three and these three only. On your test, I do take away if it's a select all and you pick a wrong answer, I do take half a point away. So make sure you only select the ones that you're sure of. Questions on this one? Questions on other questions? When? 9 on this one. And I am recording. I do plan to record my other classes. In the slides, I do have videos from last year, like the test was pretty similar last year, so the concepts on the study guides from last year should be helpful too. And again, you could always email me. You'll have time to work on your study guides again tomorrow, but if you don't ask before your test, then I don't want to hear about the bad grades. Right? So like if you're sleeping right now when I'm going over this and then you end up ineligible on grade check, I'm really not going to give that to you. I certainly don't like open up more days for tutoring. I don't care if you have a game, like it's literally my time is valuable. So if you want to sleep during my time that I'm teaching you, go ahead. All right, anyway, so number 9, comparing 2 box plots. Which statements must be true about the distributions? So we have the total number of miles driven in August is the same as the total number of miles driven in December. On box plots, can you see the total? Can you see every single data point in a box plot? So you don't have enough information to even have an opinion on that one. So we're not going to pick that one. So I don't know how many total miles are driven. So we're not going to pick that one. It says half of the time drivers went further than 40 miles per day. So find where half is on a box plot. Remember the quartiles split the data into quarters. So like 25% here, 25% there, 25%. When I say half of the time, I'm looking right at where the median is. So right at where that middle line is on each box plot. Would you say that half of the time drivers went further than 40 miles per day? Yes, this is 50% of their data. That's two quarters. And then here's another 50%. This is where it splits, two other quarters. So yes, you are going to select that one. Half of the time drivers went further than 40 miles per day. The median miles driven in August is equal to the median miles driven in December. You guys agree with that? Okay, so median is the middle line on the box. Both of them are at 40. So I think box plot is for August, the other is for December. So yes, we are going to select that one. In December, drivers typically drove more miles per day than in August. Now, when we say typical, am I asking you for a measure of center or measure of variability? Variability would be something like consistent. If it says something about how consistent something is. So when we talk about like typically, we actually are asking you to compare a measure of center. So like the mean or the median. On box plots, can you see the mean? No. You can see the median, so that's what they are probably wanting you to compare. So when they say words like typical, they want you to compare centers. So would you say that in December, they drove typically more miles than in August? Right? No, because they're the same. So we're not going to select that one. The interquartile ranges for both months are equal. Now, how do you find interquartile range? Good. That's one of the few things the calculator will not explicitly tell you, by the way. You do have to know that. And where is your Q3 on a box plot? The right side, like this very right side. So the right side of the box. Good. Okay, so this is always where your Q3 is. So here's visually where this Q3 is. And then where's Q1 always? The left side of the box. So when we're having you find the interquartile range, we'd be doing whatever this is. So like 60 minus 20 is 40. 50 minus 30 is 20. But visually, you could kind of tell who has the larger box. August or December. So even without me doing the math, you can kind of see like if it's visibly bigger, that should have the bigger IQR. So they're not equal. We're not going to select that one. The only two we should select are these two, and then we double check. Yep, the right. And remember, your study guide could be shuffled, so don't just blindly copy me, make sure you're selecting the right answers. Questions on this one? Questions on another question? Yes. Number 2 on this study guide. Okay. All right, so we have a box plot question. So they're giving us the data, they're saying which of these would best represent it. And then also some other questions about it too. For our box plot questions, I've shown you how to do it by hand, but there's a lot of like small mistakes students make. So like one, you'd have to put this data in order before you find your median. Otherwise it'll mess you up. Sometimes like people forget that when I have an even number of data points, I should be taking the average of two numbers in the middle. Like I should not just be circling one and saying that's my median. So like a lot of silly mistakes you could make. What I would do is I would put this data into Desmos, and granted, you can't copy and paste on the test, but you can write it on your scratch paper and then transfer it over. With Desmos, I don't have to put it in numerical order, so that saves me a possible mistake in doing that. Okay, so it said I had 10 numbers, and it says so in my calculator that I put in 10 numbers. So double check, sometimes you type in the wrong thing. Um, for me, if I was trying to compare it to a box plot that's already made, I'd probably do the stats function, just like that. Stats, parentheses, whatever you call your data, and it'll give you the 5 numbers you need for a box plot. I like that better than typing in box plot here or finding it in the menu because this isn't necessarily like the same, I don't know, scale as the test. So, like, it might look different. Like, this might not be as helpful to me as this little menu of numbers, which will always be the 5 numbers you need for a box plot. So I would match it up that way first. So let's see what's different between these. Okay, hold on. So I can see like the medians are different. So like B has the wrong median on my screen, so I'm not going to pick that one. C has the wrong median, so really it's now between A and D. See what else they have different. Looks like their minimum and maximums are the same, so I'm going to focus on the Q1 and Q3. So this does look like 29 there. This does look like 35 there. I'm leaning more towards A. Let's compare to D. And yeah, that would be incorrect. So A is correct, at least on my screen. Yours could be shuffled, but A is correct on my screen for the box plot. Any questions on that part? Okay, now to answer the rest, about half of the boxes sampled have weights above what weight? Where on a box plot would be like your halfway mark? The median, which is always the middle line of the box plot. And we're looking at A, this is right. And it said above what number? Well, my median is 32. So I'm gonna put 32 there. About half of the boxes sampled have weights above 32. What percent of boxes have a weight above 29? So A was the one that was correct. Let's use that one. Remember, the quartiles are where it splits into quarters. So then here's my first 25%, and second, and third, and my fourth. What percent is above 29? Good. 25 plus 25 plus 25 makes it 75%. And that is how you get that one. Good. All right, questions on this question? Questions on others? Yes, sir. Sign on the phone. And then no one asked about the constructed response. I mean, tomorrow at the end of the school day, I'm gonna post the key, so at least check it to see what the answer should look like. But for this one today, the mean vitamin C level for 20 dogs was 7.6 milligrams per liter with a standard deviation of 2.1 milligrams per liter. One dog's vitamin C level was not in the normal range. It was 0.9 milligrams per liter, which is a very low level of vitamin C. If the value 0.9 is eliminated from the data set, so if we decrease the small outlier, right? Because on the number line, if we plot this, 0.9 would be like way over here, whereas like the mean is closer to 8. If we eliminate a number to the left of the rest of the data, would that increase or decrease the mean? It would increase it. Because I'm taking away a really small number from the rest of the data, my mean should increase. Because 0.9 milligrams was an outlier. I mean, we can mathematically prove that it's an outlier too, but like I'm telling you right now, 0.9 is very far away from like a mean of 8. So you can mostly assume and be right if something's an outlier or not, or you can do the calculations. I'm gonna know if I have time to show you the calculation right now. You could also play around with Desmos and see. Then we have, if the value 0.9 is eliminated from the data set, the standard deviation, which is how spread out the data is. If I delete an outlier, would the standard deviation increase or decrease? It would decrease because I'm making it more or less spread out. And if you were really struggling with that, you could play around with numbers in the calculator. Like if my mean for something is closer to 7.6, there's probably a lot of numbers around like 7, 8, 9, if that's the case. And then that one value that's like way smaller than the rest. So like say this is my mean before I take away that really small value. Look what happens when I take it away, it increases. If I were to do the standard deviation, so here it is before I take away the small value. When I take away the small value, it decreases because that's how spread out it is. So you can play around with numbers like that and just see.